I apologize. When I was trying to complete the previous section, there was a phone call and it got a little messed up. So hopefully there won't be any breaks in the presentation. So uh, essentially, the reason for using epoxy resins for stereolithography or epoxy resins to be added to that is so that we have as little shrinkage as possible, because the earlier acrylate type of resins used to introduce quite considerable amount of residual stresses in it. So you add the epoxy resins, it can also be polyglycidyl ester or ethers or epoxide compounds in which the epoxide groups form part of an allocyclic or a heterocyclic ring system, and they would join with the acrylate type of resin systems to create the polymer chain. Now, as I said to you, one of the reasons why acrylates result in considerable amount of residual stresses is because they polymerize pretty uh, rapidly, and they would uh, polymerize to form their respective polymer networks um, in the presence of each other during the curing process. So you get an interpenetrating polymer network, or IPN. So an IPN can be defined as a combination of two polymers in a network form. One of them is synthesized and the other one is cross-linked in the immediate presence of the other. So you have the acrylate chain and you have the epoxide polymer. They would form a network of the two, and the presence of the two reduces the amount of shrinkage and residual stress. And these reactions are concurrent reactions instead of a simple mechanical mixing process. It is not a copolymer, please remember that, but it is a polymer blend that is generated from the hybrid curing. And both the acrylate and the epoxy monomers would undergo independent polymerization instead of joining together. But both are present with each other and they help to reduce the amount of shrinkage and the residual stress. There could be some cases where there could be copolymerization occurring. So in which case you have a chemical bonding of the two networks. But most of the time it doesn't happen. They react independently and they definitely affect each other physically during the curing process. The acrylate will react very quickly, but um, the epoxide would reduce the amount of shrinkage. The presence of the acrylate monomer may reduce the inhibitory effect of humidity on the epoxy polymerization, because epoxy polymerization can be affected by humidity, but the presence of the acrylate will counter that and prevent it from affecting the curing of the epoxy. Now, how quickly can you make these things react? It's a pretty complex question. There are hardly any analytical photopolymerization model that describes the reaction results and reaction rates. There is some qualitative understanding, but most of the time they are pretty complex. The reaction rate by itself has very important consequence for the stereolithography process, because higher the rate of polymerization, faster you can build the parts. Um, Now, they are predominantly composed of monomers, so you can't change the monomer concentration a whole lot. But, but the only way in which you can control the polymerization rate and the average chain length is through the concentration of the initiator. So you change the amount of initiator and it can affect the uh, polymerization rate. If you increase the inhibitor, it can increase the polymer by 2. It can increase the polymerization rate by a factor of 1.4, but it reduces the molecular weight of the resulting polymers by the same amount. Now, this is more accurate for or appropriate for acrylate resins. So, uh, it may not always work well in the presence of epoxies. There are some new types of SLA machines, and the reason for them to be on the market is because the most of the patents uh, originally issued for 3D systems are no longer valid. So these have come like, and even $3,000 is a lot. I don't know why people say 2,995 or 3,995. Nobody knows why that 99 or 95 comes into the picture. You can be pretty certain that if it says $3,000, the cost of manufacturing is only $500. So if any of you want to start making a machine, I think it'll be a very interesting um, business model. So I would like you to do a homework on stereolithography, but more in terms of what are the prices of the new SLA machines in the market, see what their capabilities are, and list them, and compare them to the 3D Systems SLA 250, which is one of the cheapest SLA machines or one of the most common SLA machines in the market, and compare their prices and see if you can get the prices for these machines from 5 and 10 years ago, and let me know what your impressions are about why the prices have dropped so much in the past 5 years or 5 or 10 years. Tell me your opinions about that. So this is more in terms of giving you an understanding of the additive manufacturing field and how these changes have happened in the last several years. Okay, so that's your homework number. Actually, this will be homework number 4. Okay, this is now let's talk a little bit about the general concepts of the SLA equipment. So there are many parts to this, and it's a very complex piece of equipment, but it is a very simple piece of equipment to operate. So these are the multiple parts of this system. I would also like you to do um, one more thing, and I would like you to find a paper from the Rapid Prototyping Journal about the theoretical relationship between resin characteristics and exposure of the radiation, and just write 1 or 2 paragraphs about the same and upload on the discussion board for everybody else to see. I would like you to do that so that others can also benefit from your understanding. Okay. Now, so let me um, stop here for this section, and I will take up the extrusion free forming in the next section.